Hey there, we're going to go through our pre-lab for our upcoming lab, which is called Hooke's Law Lab. And so measuring a force can be relatively difficult to directly measure a force. And that brings up what a famous scientist, Mr. Galileo, once said, and that is measure what is measurable and make measurable that which is not. So although it may be difficult to directly measure force, we just got to kind of figure out a way to be able to do that. And that's kind of what we're going to be doing in today's lab as we are going to measure the force exerted by a spring. So Mr. Robert Hooke, he was also an old famous scientist. He did a lot, not just in physics, but he also did a lot in biology and some other subjects. And so you may have heard about him before, but he did a lot with microscopes. And he also had a rival with Mr. Isaac Newton, who you've probably heard of, and accused him of stealing some of his ideas and publishing them. So there was a little bit of rivalry going between Mr. Hooke and Newton. So Robert Hooke, he actually made an anagram, and then when that anagram is unscrambled, it comes up with this Latin phrase, this ut tension siccus, and that just basically means as the extension, so the force. And so the hypothesis that we're going to have with this lab is that the stretch of the spring is proportional to the force it exerts. So to assist us in measuring the force, we're going to have to use calibrated masses. And that picture diagram there, those are the ones that we'll be using in our lab. We have another form of some calibrated masses we'll use later in the year. And so remember, mass and weight are different. And so we use these masses, but then we have to figure out the weight, not in pounds, but in newtons. And so we kind of went over that briefly last week. And so in order to convert from mass in kilograms to weight in newtons, we take the mass of the object and multiply it by that gravitational field strength at 9.8 newtons per kilogram. And so here's an example of how you do the conversion. And so most of the time your masses might be written in grams. So in this example here, we're starting with a 200 gram mass. And so before you can convert from mass to weight, you need to first put it into kilograms. Remember, there are 1,000 grams in 1 kilogram. So all we have to do is take our 200 grams, divide it by 1,000, and then we have 0.2 kilograms. Once your mass is in kilograms, then you can go ahead and convert it to that weight in newtons. And so you take your 0.2 kilograms, multiply it by 9.8 newtons per kilogram, and your kilograms will cancel, giving us a weight of 1.96 newtons. Remember, in our labs, we'll always use that 9.8, but on paper, we'll always just round to 10. And even on the AP exam, they just tell you to round to 10. So to measure the stretch, we're going to use a meter stick. We're going to hang those springs vertically from the rod. We have these what we call CPO stands that will have the rod in. And you can measure the initial length of your spring, and then you can add your calibrated mass and figure out how far it's stretched, okay, by subtracting the new length from your initial length, and that will give you how far it's stretched. So lastly, we'll talk a little bit about reducing experimental uncertainty. If you remember from that first week of school, I brought this up. With any lab we do, we always want to reduce that experimental uncertainty. There's various ways that you can do this, just depending on the type of lab that you're completing. You can repeat your measurements, vary something, and do many trials. Spread the trials over as large of a range as possible. And graphing the data is always best in our labs.